Hello everyone, I'm Varsha. Today I will be explaining about the topic initialization. Coming to introduction to microcontrollers. Microcontrollers are compact single chip computers that integrate a processor, memory, and input-output peripherals on a single integrated circuit. They are heart of a countless electronic devices from household applications to industrial automation system. Importance of initialization. Consistent startup behavior. Proper initialization ensures the microcontroller consistently puts up in known state, allowing reliable and predictable operations. Configuring peripherals. Initialization set up the microcontroller's peripheral modules such as timers, communication interference, and input-output pins that the applications need. Memory allocation. Initialization reserves and configures the microcontroller's memory resources, ensuring proper program execution and data storage. Power on reset and startup sequences. Power on reset. When a microcontroller is powered on, it automatically triggers a power on reset (POR) sequence. This resets the internal registers and initializes the system to known default state. Second is startup sequence. After the POR, the microcontroller begins its startup sequence. It fetches the initial program counter value from a predefined memory location and starts executing the first line of code in the firmware. Bootloader execution. In some cases, bootloader program runs first, performing checks and initialization before handling control over the main application firmware. The bootloader ensures a safe and reliable startup processes. Configuring clock sources. First is system clock selection. Choose the appropriate system clock source from your microcontroller, such as internal RC oscillator, external crystal, or external signal clock signal. Second is clock frequency configuration. Set the system clock frequency to the optimal speed for your application, balance performance, power consumption, and other requirements. Third is clock stability and accuracy. Ensure the clock source provides the necessary stability and accuracy for your system, considering factors like temperature, drift, and aging. Fourth is peripheral clock initialization. Configure the clock signals for various peripheral modules such as timers, serial interfaces, and ADCs. Ensure they operate at the correct frequencies. Initializing peripheral models. First is hardware set. Ensure all peripheral devices are properly connected and configured according to the microcontroller specification. Second is software configuration. Initialize and configure any necessary peripheral drivers or communication protocols in a firmware or software. Third is data handling. Set up a data buffers, interrupt handlers, and other necessary structures to manage data flow between microcontroller and peripherals. Setting up input-output ports and pins. Port configuration. Microcontrollers have multiple input-output ports, each with a set of pins. During initialization, these ports must be properly configured as input, output, or special function pins to meet the application requirements. Second is pin direction. For each pin, the direction must be set, whether it will be used for input, output, or special functions like PWM or ADC. This configuration ensures the pins to behave as expected during program execution. Pull up or pull down resistors. Depending upon the circuit design, pull up or pull down resistors need to be enabled on input pins to ensure a known logic state. The pin is not being driven. Alternate functions. Many pins have alternate functions like timers, serial communication, or analog inputs. Initializing these pins for their intended purpose is crucial for peripheral modules to operate correctly. Configuring timers and counters. First is timer initialization. Set the timer mode, descaler, and initial counter values to match your application requirements. This ensures accurate timing and pacing of your microcontroller operation. Second is counter configuration. Configure external event counters to track physical parameters like rotations, pulses, or other digital signals. Properly set the counting mode and edge sensitively. Third is interrupt setup. Enable timer and counter interrupt to trigger specific actions when thresholds are reached. This allows for real-time, event-driven and processing. Synchronization. Ensure timers and counters are properly synchronized to avoid race condition and inconsistent state. Coordinate their initialization and operation across the system. Initialize interrupt system. Interrupt triggers. Configure the condition that will trigger interrupt such as raising falling edges, level chances, or timer expiration. Interrupt priorities. Assign property levels to different interrupt sources to ensure critical events are handled first. Third is interrupt service routines. Write efficient interrupt handles to quick process interrupt request and return control to the main program. Memory initialization and allocation. First is memory mapping. Microcontrollers have various memory regions like program memory, data memory, and peripherals. Proper initialization ensure efficient usage and access to the memory spaces during program execution. Third is stack and heap. Second is stack and heap setup. The stack is used for function calls and local variables, while the heap is for dynamic memory allocation. Initializing the stack pointer and heap boundaries is crucial for maintaining memory integrity. Third is memory partitioning. Microcontrollers often have different memory types like RAM, ROM, and EEPROM. Proper partitioning and mapping of these memory regions during initialization ensures the program can access the right memory location. Best practices for initialization. First is modular approach. Break down initialization into smaller reusable modules to promote code organization and maintainability. Second is error handling. Implement robust error checking and logging during initialization to quickly identify and resolve issues. Third is conferable setting. Make initialization parameters conferable to allow flexibility and adaptation to different hardware configuration. Fourth is setup sequence. Carefully design the startup sequences to ensure all necessary components are properly initialized before use. Thank you for watching.